Hello everyone, welcome to my channel The Physics Chronicles. So in today's video we are going to talk about Abel's theorem in differential equation. Lot of students ignore this or either ignore this or don't know about this theorem. So let me tell you, this theorem is used to find out the linear independent solutions of second order linear and homogeneous differential equations. So this is only applied to linear and homogeneous ordinary differential equations of second order, right? So let me write down first the formulation here. Abel's theorem. Let's take a generalized form of this second order linear homogeneous differential equation. Let's say we have y double dash plus p of x y dash plus q of x y is equal to 0. As you can see here, this is second order and this is linear and homogeneous ordinary differential equation. Now in these cases we can apply this Abel's theorem. So what does this Abel theorem tell? That there is a term called Wronskian, and we denote it as W, right? So this Wronskian is determined in such a way that, let's say we have two linear independent solutions, y1 and y2. These two are two linear independent solutions of the above equation. Remember, the Wronskian is written as W is equal to determinant of y1, y2, y1 dash, y2 dash. And for a linear second order linear homogeneous differential equation, this is always not equal to 0. This cannot be 0. If you find out the determinant here, we can write down W is equal to y1 y2 dash minus y2 y1 dash, and this is never be 0. And if you see this differential equation, from this differential equation, if you want to find out the Wronskian directly, then you can find W is equal to some arbitrary constant C and e to the power minus integral of px dx. This is the general form of Wronskian. So q of x, whatever q of x may be, it doesn't matter. Only term you need is p of x. So first the equation, the given equation, you have to convert that equation in this form, find out the px, and then you can find out simply this Wronskian, right? So this is the basic formalism. You have to remember only two things here. This Wronskian can never be 0 for second order linear homogeneous ordinary differential equations, and this will be equal to, if you find out from this equation directly, then this will be equal to c e to the power minus of integral p of x dx, right? Let's take some examples. I will keep this all the time and do all the examples on this side. First example I am taking. So the question is, let's say x1 and x2 are linear independent solutions of the equation d square x by dt square plus 2 dx by dt plus f of t is equal to 0. This is the differential equation given. And x1 and x2 are two linear independent solutions of this differential equation. Then he has given that the Wronskian W at t is equal to 0 is equal to 1. Then what will be the Wronskian at t is equal to 1? This is the question. Now I just told you, you just need two formulas to find out the Wronskian. So here you can see p of x is 2. Here I am solving this problem. So p of x is 2. it is given, right? So for finding out the Wronskian, W can be written as some constant c e to the power px dx. So minus of 2 dx, that will give you c e to the power minus 2x. And there are one condition given to find out this arbitrary constant. Apply this one. So you have to put I'm sorry, this will be t actually, because the independent variable is t here. Here also t, right? So w at t is equal to 0 is equal to 1. So w will be 1 and e to the power 2 into 0 will be 0 and e to the power 0 will be 1. So it will be c. That implies we can write down a Wronskian as w is equal to e to the power minus 2t. And he is asking to find out the value of w at t is equal to 1. So this will be e to the power minus 2. This is the answer. So you can see how simple is this. And the second problem, he has taken, there is a differential equation given again, 1 minus x square y double prime minus 2x into y prime plus y is equal to 0. This is the differential equation, and he has given that w at 0 is equal to minus 1, and we have to find w at e. Right, so it will solve here. You can see the differential equation here, 1 minus x square y prime y double prime minus 2x into y prime plus y. Just I told you that you have to convert this in this format. You have to find out the px first. If you divide 1 minus x square in the entire equation, then here you will get p of x is equal to minus 2x by 1 minus x square. So p of x here is equal to minus 2x divided by 1 minus x square. And for Wronskian, w is equal to e to the power c, there is a constant c, and e to the power minus of integral p of x dx. But here there is another negative sign. So minus into minus becomes plus, and here you can write down 2x dx divided by 1 minus x square. If you do the integration here, then you can substitute 1 minus x square something, and doing all the calculations, you can see here e to the power minus log 1 minus x square, because the differentiation of this one will be minus 1 by 1 minus x square, and another again we have to take the differentiation, that will be minus 2x. So this will give you this one. So if you see and use the properties of logarithmic, you can do here c e to the power, this minus 1 goes here, so you can write down minus 1 here, and e to the power log something will be something, so this will give you c divided by 1 minus x square. And he has given some condition here, w at x is equal to 0 is equal to minus 1, so you have to put w is equal to minus 1 and x is equal to 0. So c will be equal to minus 1. Now put this and find out the value of w. This will be 1 minus x square minus 1. And w at e will be 1 by e square minus 1. This is the solution. So now you can see how simple the problems are. Now let me take a little bit higher standard problem based on this Abel's theorem. How you can use this Abel's theorem actually. I told you only two formulas to remember. One is this Wronskian cannot be 0 for second order linear homogeneous ordinary differential equations. And to find out directly from this given equation, you have to convert this equation in this format and then find what is the px, and then you can use this formula. Now the third question is very important. So the equation is given as x square y double dash minus x y dash plus y is equal to 0. And he has given that one linear independent solution is y1 is equal to x. He has given one linear independent solution and he is asking what will be the second linear independent solution. So let me tell you, the options are log x, then x square, third one is x to the power minus 2, and fourth one is x log x, right? So now let's try to solve this problem. So he is given one linear independent solution, right? You have to find out the value of second linear independent solution. For that, let's say there are various methods you can do by using this Wronskian. Let's do this by first method. This will be, you can find out the Wronskian. This will be y1, y2, y1 prime, y2 prime, and its determinant. y1 is x here. Put this value. This will be x, y2, and the y1 differentiation of x with respect to x will be 1, and y2 prime, and its determinant. And if you find out this determinant, this will give you x y2 prime minus y2, and this is the value of w we get. And I told you we can find out this Wronskian from this equation directly, but you have to convert this equation in this format. So for that we have to divide x square everywhere. By dividing x square, you will get the equation as y double dash minus 1 by x y dash plus y by x square is equal to 0. You know, I told you that q of x doesn't matter what it is. We have to take only this p of x. So by taking p of x, you can find out Wronskian, that will be some constant e to the power minus of minus 1 by x, that is 1 by x dx. And this is c e to the power log x. This will give you c into x. This one. Right? So what you got, Wronskian is equal to c of x. Now take this value and put here. What we will get? Finally, you will get cx is equal to x y2 prime minus y2. Right? Now you can see here x dy2 by dx minus y2 is equal to cx. You can see here, just divide x everywhere. You will get dy2 by dx minus y2 by x is equal to constant c. And you can find the integrating factor, and finally you can get y2. How? Let's see. So integrating factor in this case will be e to the power minus 1 by x dx integral. This will give you e to the power minus log x, and this is 1 by x. So you can simply write y2 divided by x is equal to c into 1 by x dx, and this will give you y2 divided by x is equal to c into log x. We will neglect the arbitrary constant because he is asking the linear independent solution. He is not he doesn't care about the arbitrary constant, because if you see those options, there is no absolute arbitrary constant involved, right? So you can just take what is the form of that linear independent solution. So finally you can get y2, take this x to this side, this is cx log x. So this is the second linear independent solution. So right option is D. Right, you can see how he is framing the question. The question maker is framing the question by using this Abel's theorem. So he can give they can ask another independent solution, linear independent solution, by giving one linear independent solution, and they can ask to find out the Wronskian. Simply Wronskian they can ask, and they can ask for some mathematics, that is Wronskian at some value of t or x. Like this, we solved 3 questions. Now let's take the 4th question. This is the last question in this video. So he is given that there are two solutions already given. He is saying that let's say y1 is e to the power t and y2 is equal to t into e to the power t. And he is saying that these two constitute a fundamental set of solutions to, so this y1 and y2 constitute fundamental set of solutions of a linear homogeneous second order ordinary differential equation. So he has given two solutions which gives the fundamental set of solutions, that is the linear independent solutions. Don't get confused by seeing this term fundamental set of solutions. This only means that these two are linear independent solutions, right? And he has given four options which contains a pair of solutions, other solutions, and he is asking which of these options don't represent the other fundamental set of solutions. So the options are, remember, A is y3 is equal to e to the power t plus 3 and y4 is equal to e to the power t minus 2. B, option B is y3 is equal to e to the power t and y4 is equal to t plus 1 into e to the power t. C, third option is y3 is equal to e to the power t plus 1, y4 is equal to t plus 1 e to the power t plus 1. And last one is y3 is equal to 2e to the power t and y4 is equal to minus t e to the power t. Right? So these two are linear independent solutions. How I am saying that fundamental set of solutions is a linear independent solution? You can see linear independent solutions means we cannot express one solution in terms of other. That is the scalar multiple of other solution. You can see here there is a variable involved with this. T is multiplied with this solution. Right? So we have to see which of these options don't represent the other fundamental set of solutions. I told you there are only two concepts. One is we have to find out the Wronskian by using this method. And remember, for this linear homogeneous second order ordinary differential equation, this Wronskian cannot be equal to 0. Okay, so we have to use this concept in this problem. Let's take a first option and find out what is the Wronskian value. So option A I am taking, W is equal to, y3 is this one, so we must write e to the power t plus 3 and then e to the power t minus 2. Then we have to take the differentiation of both the solutions with respect to t. So differentiation of e to the power t plus 3 will be e to the power t plus 3 and differentiation of t plus 3 is again 1, and similarly here, and you have to find out the determinant. If you see the determinant, then both these will be equal, that is e to the power t plus 3 plus t minus 2 minus e to the power t plus 3 plus t minus 2. So these two are equal, so that will give you 0. So this option A cannot be a fundamental set of solutions for this differential, for the given linear homogeneous second order differential equation. So these are the concepts of Abel's theorem. The question maker can ask you to find out simply the Wronskian, as we see in the first two examples, and in the second two examples I used this concept. And first we have to find out the W value using this one, then equate it to this one. Then we can find out the second linear independent solution. Or another way to find out that, check the options. in the third question, I wrote down 4 options here. You can simply check the options and which one is giving non-zero value or which one is giving this Wronskian. First find out this one and equate this, see which option gives you that W value, right? So this is the way to use the Abel's theorem in differential equation. And in the next video, I will tell you how to solve the coupled system or coupled differential equations. And in the JEST 2020, recently they have asked a question based on that, and we will solve that too. Okay, so we will see in the next video. Till then, stay home, stay safe, and take care of your family. Bye bye.